Alrighty, let's return to all the fun we were having before my nephew came and the dogs went crazy. So this is graphing calculator. This is going to be the instructions that are in your notes. You do have to know how to do it. I unfortunately am not going to be telling you what to do during the test. So make sure you've practiced the steps of finding what you need. Okay, so I'm going to type this into the y equals of my function. And then I'm just going to kind of sketch it, to be honest. So I'm going to have like this is kind of what I see. Then I'm going to use my calculator and I'm going to find my max and mins because I need to. So the key points will be this point because that's one of my zeros, this point because it's a max, this point because it's a minimum. So I need those 3 points. I need my 0 or my y-intercept. That'll help me with positive and negative. Max and mins will help me with increasing and decreasing. So that 0 point right here, I'm gonna go to my calculator and I'm gonna go second trace 0. It's gonna prompt me to go to the left, the right, and so on. And then you should get these exact numbers. Like you should have the same exact thing. If you typed this in and then do the process correctly, you'll get the same values. Then my max is located at, same thing, I'm going to go second trace max, get to the left, get to the right, hit enter. And then when you're trying to figure out how far to the left and right to go, there's not like a right answer, except that you only want to stay around this one curve. If you open it up wide enough to be around the whole thing, it's not going to give you the right answer half the time, kind of depending on what's going on. So this maximum point on my calculator, I got negative 0.577 for my x and 1.770 basically for my y. That's this. And then my minimum, which I can't fit because I have messy writing, I'll write up here. And that's this guy. And it looks like it's at 0, but it's not at 0. It is at 0.577.230. And that is going to matter because I need these x values for determining my intervals. So where is this graph going to increase? Well, this graph increases from here until here. All right, well, that is from negative infinity until I hit the max, and the max has an x coordinate because that's all I use per my vow to only use x coordinates in intervals like that. So that is my first area of increase. It also increases from here on over. So this point is my minimum, which has an x value of 0.577. And then it goes up forever, which is infinity. And none of those are included because I'm doing increasing and decreasing. And those don't include the places where it changes from one to the other. The part that decreases is from here on down. Right there is my area of decrease. So from the max to the min, which means I'm going from the x coordinate of my max to the x coordinate of my min. Okay, where's the graph positive? Positive is going to mean anything here, keeping in mind that this is not going to be included. So positive and negative is related to the 0 or the x-intercept. And so now I'm looking for the place where it's positive, which is this part here. And that is from my 0 on. My 0 x coordinate is at negative 1.191. I'm looking right here. And it is positive until forever. So that goes to infinity. Where is it negative? Well, it's negative down here. It's below the x-axis here, which is from negative infinity because that's forever on the left end until it hits this 0 or x-intercept, which is again at the negative 1.191. Always parentheses on that because this particular spot right here is a 0, and 0 is neither negative nor positive, so I can't include that. Okay, X-intercepts, that is my 0. I found that on my calculator, so negative 1.1910. Y-intercepts, that is where it crosses the y-axis. That is going to be what you get when you put in a 0, because to be on the y-axis, you need to have 0 and then a number. So I actually just look back up here, put zeros in for my x's, and I'm going to find out that it is at 1. This is giving me an x coordinate, and so it's asking me to plug that number into this equation for all of the x's. And when I do that, it's strictly a calculator thing, I get, oops, sorry, that's an 8. This last one is asking me to do something a little different. It's asking me to figure out when is the y value going to be 2. So I need to go to my calculator. I'm going to go to y2, the second function, and I'm going to put in the number they're asking me about. And when I hit graph again, that line is going to shoot across here at 2. And what I'm looking for is any place the graph hits it. This particular one only has one intersection. So for these problems, you're going to have to use a function on your calculator under second, trace again, but this time you're looking for its intersection. Where do they cross? So you scoot over to be by that point. It'll say first curve, second curve. It's asking you, and if you look up at the top corner of your calculator, it'll show the equations. So you basically just hit enter 3 times, and it's going to tell you where they cross. So that is actually at an x value. That's what it's asking for. They cross where x is 1.191. Absolutely need to know how to do this, but again, focus on like this one and the number 8 in the worksheet from that day. The 9 and 10 are far more complicated than is reasonable for the test. Okay, this goes on then to 1.4, where we are looking at transformations of the graphs. So here, this is the square root. We talked about that before and knowing the parent graph of that. So I'm going to do the parent graph in gray. Square root of 0, square root of 1 is 1, square root of 1, 2, 3, 4 is 2, and then I kind of know the general shape. Okay, so that's my f of x. This one, the g of x, that one is going to do what? Well, this is going to move it up 2, left 1. So you can create the table, or you can take the points and move each one left 2, up 1. Move the next point. Left 2, up 1. Except for I am having a brain fart because, let's start over. This is going to move it left 1, up 2. I'm not sure what I said initially, but it's late and I'm confused. So, because this is in the container, it does the opposite of what you think. So I'm going to move each point to the left 1, up 2. That feels more right. To the left 1, up 2. Move this point to the left 1, up 2. It does not change the shape. It simply changes the location. And so this is function g. Let's try that again. What's your parent graph look like here? You should know that right away. You should be able to go, oh, that is a quadratic. My parent graph is a parabola. 1 squared is 1. 2 squared is 1, 2, 3, 4. Same on this side, because when I square negatives, they always turn out to be positive. So that is my original function, f. What things are happening in the next one? It's going to flip over. It's going to be stretched by a factor of 2 vertically, and it's going to move 1 to the right. Okay, so it's going to flip over the x-axis. So again, if you want to build points, you can, or you can simply look at one point at a time, and you can say, okay, this point, let's try. If I flip it over the x-axis, it's not going to move. If I multiply that 0 by 2, it's not going to change, because 0 times 2 is still 0. So that point is only going to do this one thing, which is move to the right 1. So this point ends up here, my vertex. it'll still be the vertex. This one is now going to open down and be skinnier. So what I kind of do to cheat is with these, I use these 3 guide points. And since this was a 1, 1, I think, okay, what if I took that and I did this to it? Like the slope to get from here to here is 1, 1. You can't keep going because obviously it's not a straight line. But to get to that first point, I went up 1, over 1. Well, according to this, from my vertex, I'm going to go down 2, over 1. And that has a mirror image over here because it's a parabola, which means this one would have a mirror image right here. Okay, and so I have moved it to the right one. I have flipped it over, and it's twice as skinny. So this is going to be my new graph. Now, I could write out the points for x squared and then do these things to the values. That would work too. But when I'm done, I look and go, does this second graph that I drew, is it flipped over from the first? Yes. Is it skinnier by a stretch value of 2? Yes. Is it moved to the right one? Yes. Parent graph for absolute value looks like a V. Absolute value of 1 is 1, 2 is 2, 3 is 3, and so on. Same on this side. Absolute value of the negatives is the positive version of that same number. That is my original function. Now let's take a look at what happens when we do these things. This is going to move it to the, this is going to move it down 1. This is going to move it to the right 1. This is going to make it 3 times steeper. So if you look at this one, it currently has up 1, over 1, up 1, over 1. So now we're going to need to actually have a slope of 3. It's got to be stretched 3 times taller. It's not flipping over. And we're also going to move it to the right and then down. So I'm going to take my vertex because that's the easiest point to move. And I'm going to move it to the right 1, right 2, and then down. That is my vertex. I'm not flipping it over. I did the down 1, right 2. Now I just have to multiply my sides 3 times taller. So instead of going up 1 over 1, I'm going up 1, 2, 3 over 1. And then 1, 2, 3 back 1 to get the mirror image of that, because it's still going to be it's still going to be that V shape. It's just going to have a slope of 3 going up so that it's 3 times steeper. Okay. This should be pretty quick. This part I feel like most of you know what you're doing. Is it a function, yes or no? If not, explain why not. Sketch C and D. Okay. So when I go to look at points, I'm looking to see if any of the x's repeat. So 3, 2, 5, 0. Since none of the x's repeat, that is going to be a function. Here I look at my x's, 2, 4, 2, 6. So this is problematic. You can't put a 2 into the function and have it kick out a 0 one time and a 5 the next time. So this is going to have to be a no, and it says to explain. So I would basically say something that explains that I have 1x going to 2y's. C and D, it says to sketch them. Well, this is the parent graph for a parabola, so I have a pretty good idea of what that looks like by this time in my math history. And then I'm going to be using the vertical line test. So that is a yes, that function passes the vertical line test. Now this one you have to kind of think a little bit. Y squared is going to be your x. So if I have a 0... it doesn't matter because 0 equals 0 squared. That's the only point. But here, this is going to be the situation. Because if my x is 1 and that equals y squared, it could either be a 1 or it could be a negative 1. Because when you square a negative 1, you still get a 1. So I have this going on. So this turns into a sideways parabola because squared always makes a parabola, but because the y is squared rather than the x, and if you look back at your homework, I said to watch for those red flags, like absolute value of y creates a sideways V shape. Y squared creates a sideways parabola. And the reason this is going to have to be a no then is that this fails the vertical line test. Because if I come cruising through here with vertical lines, it's crossing in more than one place. So each x has two y's, and that is not acceptable. Okay. This is finally the last page. These questions actually turn out to be really confusing, and you really got to understand your stuff. Whenever you have like concept questions, they're going to be real tricky. If you're in physics, you're going to know what I mean, that the concept questions are always trickier than the math questions. Okay. These are regarding even and odd functions. Keeping in mind that with an even function, if you have an original point of xy and it's going to go to an even function, that means when you change the signs of the x's, the y's stay the same as they were. And if you're going to go from this original point to something in an odd function, when you change the x's, the y's change also. So if you plug in a negative x, it will equal the original function. If you look back at your notes, that is going to be the description for an even function. You switch out the x's for a negative x, you end up with the same thing you started with. This is straight out of your notes from that day. Here it's saying when you switch the x's inside here to the opposite, you actually get the total opposite of what you started with. That is the definition or description of how you know that a function is odd. I think it's easier for most people to work with an actual point. So if that's my original point, 3, 2, name another point if it's even. Well, let's go back to what I was saying up here. This is the point they gave me. If it's even, I can change the sign of the x's. So from a positive 3, it becomes a negative 3. But in an even function, this y is the same as the original. So the same as the original means my y value would be a negative 2 from this point is what I'm working with. What if it's odd? Well, even and odd, in both cases, you change the x to the opposite of what it was. But in an odd function, based on what we're saying right here, this becomes the opposite of the original as well. So since the original was a negative 2, this becomes a positive 2. Same thinking here. I need to make the x the opposite of what it was, but keep the same y, because that's the thing with even. With odd, when I change the x to the opposite of what it was, and by that I mean this was a negative 8, now it's positive, the y changes as well. So it went from being a positive 6 to a negative 6. And same exact concept here. Here's my original point. I switch out the x's. For an even function, the y stays the same as it was. Here I switch the x again, but in an odd function, the y becomes opposite as well. And same thing. Here, switch the sign of my x, so it used to be negative, now it's positive, but my y stays the same. And if it's odd, when I switch the sign of the x, the y also switches. So it used to be a negative 5, now it is positive. So this is telling me what to do, and this was what we did in our notes. To decide if something's even or odd, we take the function they gave us and we put a negative x in for everything that used to be a positive x or a regular x. Then we go ahead and do our simplifying. This part is a negative to a cube, which will actually stay negative. This part here is multiplying 3 times negative x. So when I'm done, I would have negative x cubed minus 3x. It's not my answer. What I do is I compare that to the original. This was a positive x cubed. This is a negative. So that one switched. Positive 3x minus 3x. So my result is the total opposite, meaning every term changed signs from the original. And when that happens and you end up with the exact opposite, it makes that an odd function. Here I'm going to do the same thing. This is a slightly different slightly different function, but I'm still going to plug in a negative x. That's what you do every single time that you are trying to test for even, odd, or neither. So here I have a negative squared, so that's going to be a positive. And then I'd have positive 3 times negative x, so minus x. So once I'm done, I compare back to what I started with. My x squareds stayed positive, and my, oopsie, I forgot to write my 3 in here, sorry. My 3x part, that was originally a positive, and now it's negative. So in this problem, one of them changed signs and one of them stayed the same. So that's going to make it neither. If the entire thing's identical to the original, it's even. If every term is different than the original, it's odd. If you kind of get a mixed bag and 1 or 2 become positive and 1 or 2 stay the same as the old one, then it's just neither. Okay, this one's a little tricky because when you go to plug in a negative x, this first negative is a part of the function, and then you put your negative in here. When I go to figure that out, this part's negative because I have a negative to an odd, but that gets multiplied by another negative and is going to become positive x cubed. Sorry, I'm looking. Oh, I see. I was looking at the wrong problem. Okay. And then minus 2x and a minus 1. I take this, I compare it. Are they exactly the same? No, because this was positive and now, or excuse me, it was negative, now it's positive. This was positive, now it's negative. This was negative, stayed negative. So because the first 2 became the opposite of what they were, but the last one didn't change, this one is also neither. Has to be original, same as the original to be even, total opposite to be odd. This one's a mixed bag. Okay, I feel like this is overkill, but we'll do one more. So negative x to the 6th minus a negative x to the 2nd plus 3. This is a negative to an even, so it will become a positive. This one's tricky. This is a negative to an even, so that'll become positive, but there's a negative out in front that makes the entire term negative. So now when I look at this and I compare it to my original, every single term is the same. A positive x to the 6th, a negative x to the 2nd, and a plus 3. And that makes it even. And then this last one is just matching, and it's a little tricky to tell, but this is going to be the one that's, that's going to be the original right here. So this is just testing your understanding of what the placement of stuff does. This is going to flip it over the x, so it needs to be upside down, and this is going to move it 4 to the right. So if you needed to flip upside down and be moved 4 to the right from where it was, you're going to be looking at this one right here. And this thing is A. Okay, how about the second one? The second one is saying that it's going to go from this to the left 6, and this is up 2. And it's all starting with the blue one. So if I go to the left 6, so from here I'm going over 1, 2, 3, 4, 5, 6, and then up 2, I'm going to be at this one, which is E. Right here, it's saying take the old one and do this to it. This is after the container, it's after the function, so that's going to be down 5. Always starting with the blue one, if you just move that thing straight down 5, you're going to be right here at B. Here, this is going to move it to the right 1. This is going to move it up 3. Again, starting with the blue, if I went to the right 1 and then up 1, 2, 3, I'd be on this one. So that matches with G. And then here, we're actually winding down. Yay. This is just going to move 5 left. So taking the blue one and moving it 1, 2, 3, 4, 5 left puts me here at D. I'm going to guess the last one is C, but aside from guessing, make sure you kind of get this one because this is going to flip it over the X, so it's going to be upside down, but this is going to flip it over the Y, and this is going to move it down 2. So this blue thing, if you flip it over the Y, is going to end up over here. And then if you flip it over the X, it ends up upside down, but it also got moved down 2. So partly by process of elimination and partly by knowing stuff, it's at C. I am done, and I hope it helped you to be able to find some of these on here. That is a lot of work, so take pride in the fact that you know how to do all this stuff, and it's only chapter 1. To be quite honest, the majority of this is algebra 2. We have done it before. So create your note card. Remember to do any homework that you do, you want to be doing for understanding, not points. And just get yourself in a spot where you can feel pretty confident coming in Friday. Make sure your calculator's charged, or if you have a battery one, get it batteries. And have your graphing calculator along because you can't share it and I don't have any extras to give to you. And I want you to be super duper successful on this first one. So use all the resources you can to feel like you're confident about the material. See ya. Bye.